This is Mr. Martin. These are video notes for advanced pre-calculus. We're in Unit 6 and we're talking about graphing cosecant in this video. So again, we've got our basic standard form here. We could have y equals or f of x equals or h of x equals. It doesn't matter. And we've got d plus a cosecant bx minus c. Same standard form that we use for every other trig function. We're just substituting in cosecant for one of the others. And remember that the cosecant of x is the reciprocal of the sine of x. So now we're going to be taking the reciprocal of our y coordinate as we travel around the unit circle, either in a positive direction or a negative direction. So let's get our unit circle down here again. I've got 1, 0 at 0 and 2 pi. Up here at pi over 2, I have 0, 1. At pi, I've got negative 1, 0, and then 3 pi over 2, I have 0, negative 1, and then again back here to 2 pi. So, and if you recall from the last video, when we're talking about the reciprocal of 0, 0 could be written as 0 over 1. And when we take the reciprocal of that, we would get 1 over 0. You can't divide by 0, and that's where we're going to be undefined. So again, we're looking at the y coordinates now. So at 0, we're looking at the y coordinate, which is 0. So that means when we take the reciprocal, our value will be undefined. So in a similar manner to graphing secant, anytime we have an undefined value, that's where we're going to have an asymptote. At pi over 2, the sign is 1, so the cosecant will also be 1. At pi, the sign is 0. So the cosecant will be undefined. At 3 pi over 2, I have negative 1. So the cosecant will also be negative 1. And then back here at 2, I've got 0, reciprocal of which is undefined. Alright, now traveling in a negative direction, so going clockwise from 0 down to the bottom, that would be negative pi over 2, which is the same as 3 pi over 2. My sign is negative 1. So my cosecant is also going to be negative 1. Over to pi I have 0. Cosecant is undefined. Again, if you have any questions about where these values are coming from, make sure that you pause the video and write those down, or pause the video and ask me right away if you happen to be watching in class. Negative 3 pi over 2, we're going to come all the way around up back to the top. The sign is 1, so the cosecant will also be 1. Remember, reciprocals are two numbers whose product is 1. When we multiply them, we get 1. So they both have to either be positive or both negative in order for the product to be positive 1. Alright, and then at negative 2 pi, we're back over here. The sign is 0, so the cosecant is going to be undefined. So let's go ahead and again put in our asymptotes. So now we see our asymptotes are at all the multiples of pi. So I have an asymptote here at negative 2 pi, negative pi. There's one at the y-axis, so we don't really need to draw that in. And another one at positive pi, and another one at 2 pi. And we'll go ahead and put in the other points that we have here. So negative 3 pi over 2, I'm going to have positive 1. Negative pi over 2, I have negative 1. Pi over 2, I have 1. And 3 pi over 2, I have negative 1. So I have these points. Let's just look at the positive part of this graph from 0 to 2 pi. So we're going to fill in these values the same way we did before. I'm not going to cover it in as much detail. I'm just going to kind of estimate some of these points. So the pi over 4 is on either side here. We're going to have values somewhere right around here and here. And then coming in between, we're going to have values right about 2. That'll be our reciprocal of a half. Again, if we draw on the smooth curve, it's going to look something like this. So this is actually half a period of the cosecant. And then same thing over here, just kind of estimating some other points in between. And normally we won't do this, but we'll just do it for these examples, it's going to look something like this. And here we have 1 period of y equals cosecant x. So 1 period of y equals, or f of x equals, however you want to write it, cosecant x. So that's what we've got here. Alright, and we'll go ahead and we'll just kind of sketch in another one. Eventually, after you do this a few times, you'll get the hang of it. So I know that I'm going to have another half a period that goes this way. These are sort of parabola shapes. And we're going to have another half a period that goes this way. So in total, we have 2 periods of y equals cosecant x. Again, the highlighted part here is what 1 period looks like. It's these opposing parabola shapes. So again, if you have any questions about how to do these, make sure you ask. Let's do one more thing before we move on. I'm going to kind of I'm going to dot in the sine curve. So the sine curve is going to look something like this. And when we do this when we're graphing these in general, we are going to dot in our sine or our cosine curve, and it's important that you make it dotted or dashed because it's not actually part of the curve. We're just using it to kind of help us. So you can see I have these U-shaped pieces of the sine curve, and then all I do is to get the cosecant is I flip it and have it approach the asymptotes. Alright, so here's my red sine curve that runs through there, and here's my 4 half periods for my cosecant. And that's going to be it for this video. Again, if you have any questions, make sure you ask, and we'll see you next time.